Hello, Design class. This is your instructor, Mr. Mandolinich, and here we're going to be starting Chapter 12, Shaft Design. Chapter 12 is going to be divided into 3 lessons. The first one is today, this lesson here, and it's about power transmission and the forces caused by spur gears. The objectives for this chapter are: Number 1, propose reasonable geometries for shafts to carry a variety types of power transmission elements, providing the secure location of each element and the reliable transmission of power. Number 2, and this is important, compute the forces exerted on shafts by gears, belt sheaves, and chain sprockets. Number 3 is determine the torque distribution on shafts via power transmission. Number 4 is to prepare shearing force and bending moment diagrams for the shafts, and these will typically be in 2 planes, so there will be 2 shear and bending moment diagrams per problem. Number 5, consider the influence of shaft rigidity on its dynamic performance. Number 6, solve problems involving power transmission through shaft rotation, including A, torque calculations for spur gear, chain, and belt drives, and B, draw torque distribution diagrams. C, calculate forces on shafts due to the transmission of torque. And finally, D, draw shaft shear and bending moment diagrams in 2 planes based on the torque transmission forces. Here we have a typical shaft. Okay, what we have is we have gears at a power input, that's at the far left end, and we have another gear at the output of the shaft, and that would be at point C. And then we have 2 bearings. Now in Chapter 8, we talked about all the kinematics that had to do with spur gears. And in Chapter 9, we also talked about the forces that were used for power transmission on spur gears. Okay, and then so what we have is something like this. We look at the forces that are in the shaft based on the operation of the gears, and then we look at what the forces are at the bearings, because the bearing locations have to react all of those forces. A little review here. In Chapter 9, we learned about how forces acting on spur gear rotate the shaft that the driven gear is keyed to. Okay, so what we have here is we have a tangential force. That's what we've seen here, this tangential force here, which operates and pushes the gear along. And then we have the normal force here, which is this pressure along the pressure angle line. And then we also have the radial force. So what's going to happen here in a nutshell is that these tangential forces and radial forces are going to be transmitted through the shaft and back into the bearings. Those are the things we're going to study in this chapter. Okay, now, if you remember in Chapter 9, we learned about equation 910 that allows us to calculate the torque in a shaft that's based on the amount of power that's being transmitted. Now that equation is torque equals P over omega, which is the angular velocity of the shaft. Excuse me. So when we go through the unit conversions with 550 foot-pounds per second per horsepower and 2 pi radians per revolution, 60 seconds per minute, we end up with the canned equation. T equals 63,000 times P divided by N. Now, as you recall, that equation works very well for us if we understand that torque is in units of pound-inches, speed, N, is in units of RPM, and P, power, is in terms of horsepower. Okay, so to reiterate, this is the equation that we use to calculate what torque is being transmitted by the shaft when it's transmitting a certain level of horsepower at a certain speed. The other thing we learned in Chapter 9 was that the tangential force, and that's the force that actually works to push the gear along, the pinion acts on the gear to push the gear along to transmit the power. That tangential force is 2 times the power divided by the diameter. That would be the pitch diameter of the gear or the pinion, depending on which shaft we're talking about, and also divided by N, which is the speed in RPM. Now we give you the equation here, equation 9.8, that says the tangential force is 126,000 times P divided by N divided by D. Okay, now we're going to use a different equation in chapter 12 to calculate what the tangential force is, because in chapter 12 we typically have the torque in the shaft. We'll calculate the torque first based on how much power we're going to be transmitting, and then we'll convert that into the tangential force. Okay, so this is going to be equation 12.2. Equation 12.2 says that the tangential force equals the torque that's being transmitted divided by the diameter, which is the pitch diameter of the gear or the pinion, whichever one you're looking at, that's connected to the shaft, that's keyed to the shaft, also divided by 2. And this is in units of pounds. Then the other force we need to calculate is the radial force. Again, this was from chapter 9. So in chapter 9 we learned that the radial force acting between the pinion and the gear can be found from equation 9.11, where phi is the pressure angle of the gear pair. Okay, so the radial force equals the tangential force times the tangent of phi. Now a lot of this is a review, but we're going to be using this in chapter 12 once we start looking at what are the forces that are being transmitted back into the shafts. Okay, the forces acting on the spur gears are transmitted to the shaft, and then they're reacted at the bearing locations. And I have an illustration of that out of your textbook. Again, this is a cartoon from chapter 9. Okay, so what we're showing here is we're showing the tangential force. This would be on the gear pair, for instance. This is the tangential force. It's acting in one direction. And then we also have the radial force. So we have 2 force components that go into the transmission of power on a spur gear pair. Okay, and those forces are reacted by the bearings. That's what we're showing here. So these are the reaction forces on the left bearing, the reaction forces on the right bearing, and then we also have the radial forces being reacted at the bearing locations as well. Okay, this in a nutshell are the things that we're going to be studying in this chapter. Is we're going to have transmission of horsepower through our gear pairs or through our pulleys or through our belts, and we're going to look at what the forces are in the shaft and to be able to determine what the shear and bending moments are in the shaft based on these reactions. So what we have here is we have the bearing locations are reacting the forces due to power transmission in the shaft. Now the one thing I want to talk about here is you can tell, look at the directions of these forces, okay? So the tangential force here is acting in one direction. The reaction forces are acting in another direction. Now, when you're talking about shafts, you need to understand what kind of shaft it is. Is it the shaft that's doing the driving, or is it the shaft that's being driven? Because that will help you to determine what the direction of the loads are. That's the tangential force and radial force in the shaft. So that's why I put together this slide here, which shows, this is again figure 12.4, that shows the reaction forces. Okay, so what we have here is in this case the gear A drives gear B, and then what we're showing on this one, we're showing the directions and of the driving. These are the action forces. So WT acts to the left and WR reacts down. Okay, and then if you're talking about the reaction forces on the gear that's doing the reacting, the driven gear. WT is now acting to the right, and WR is again acting up. So it's very important that we get our load directions right, so when we draw our shear and bending moment diagrams, we're going to get the right forces in the right directions. So, directions for forces on mating spur gears. Representing the forces on gears in their correct directions is essential to accurate analysis of the forces and stresses in shafts that carry the gears. Okay, so now I want to talk about what your assignment is. Okay, so the first thing I want you to do is to go in and download and print out the assignment for Chapter 12. Okay, you can play this lesson back as you're trying to work Chapter 12. I'll also point the PowerPoint so you don't have to hear me talk and you could just flip through the PowerPoint. So as part of this lesson, this is lesson 1, I want you to complete the first page of the assignment and submit it via the Dropbox. I've had some questions on how to do that. I'm working with Tyler to try to figure out if we can, you just take a photo of it. If you have a scanner, that would be ideal. You can run your homework through a scanner and then just take the PDF or whatever file format you get from your scanner and then load that format in the Dropbox. Now I'm having multiple submissions allowed in the Dropbox because I'm going to have you do this homework assignment piecemeal. Like as we go forward, I'm going to show you what we're going to do on this homework assignment, and I want you to submit the portions after this lesson. So the idea for me is that after this lesson, you're going to work a part of your homework assignment, upload it to the Dropbox, scan it and upload it to the Dropbox, and then after that you can continue with the second lesson in this chapter. Okay, so let's talk about the problem itself. The problem itself is this spur gear. Well, it's a power transmission shaft. The description says the shaft is rotating at 200 RPMs and carries spur gear C, which has 80 teeth with a diametral pitch of 8. From that, you can calculate your pitch diameter from the kinematics in Chapter 8. We talked all about that. It's giving you that the pressure angle is 20 degrees, and the gear delivers 6 horsepower to a pinion directly below it. Okay, so in this particular part of the problem, we're just talking about looking at the power that's being transmitted from gear C, right here, to gear Q, which is right here. So this is just the 6 horsepower that's coming off of this shaft being transmitted to gear Q. What we are to do is to calculate the torque delivered to the shaft. I've covered that, how to do that in this presentation. To the shaft to gear C, and the tangential and radial forces exerted on the shaft. So this is the first part of the problem that I want you to solve for lesson 1. So let's talk a little bit more about this assignment. Okay, well, first of all, problem 12.2 is part of a larger problem we are going to work through together. The total problem will be worked over 3 lessons that comprise Chapter 12. For this shaft, the power is received at the left end of the shaft via a flat belt pulley, and we're going to talk more about that in the next lesson. This power is also distributed to gear Q via pinion C, and then it's also distributed to the chain drive at the right end of the shaft. Okay, so we have power coming in at the left end of the shaft. We have the gear at C transmitting power to Q, which is the first section of this problem. And then we also have a chain drive at the right end that's going to be taking power away from the shaft. Okay, so in a nutshell, that's what the problem is going to be. For lesson 1, I want you to complete problem 12-2 and submit to the Dropbox before proceeding to lesson 2. For problem 12.2, you are to compute the torque, the tangential force, and the radial forces due to the power transmission from pinion C to gear Q. And then you should be able to do that by following the equations in this presentation, and then also the spur gear kinematics that we studied in chapter 8. Now, here's where we're going with this. The solution will finish in the drawing of shear and bending moment diagrams of the shaft in both the vertical and horizontal directions. Now, to help you with this, I provided the third sheet in the assignment, and that's going to be the sheet that we ultimately end up drawing our shear and bending moment diagrams on. So what I want you to do is start completing sheet 3 of the assignment by drawing light lines on the page as shown in the next slide. This is where you're going to be constructing your shear and bending moment diagrams. Now notice how we have one shear and bending moment diagram that's going to be drawn in the horizontal plane, and then we have another shear and bending moment diagram that's going to be drawn in the vertical plane. Okay, now why do we need to do that? Well, because in the first part of this problem we have a spur gear, and the spur gear has two forces, the radial and the tangential force, and both those radial and tangential forces are going to be transmitted into the shaft. Okay, so you must draw the loading diagram before you can start your shear and bending moment diagrams. So after you finish the assignment, which is calculating the radial and the tangential forces on gear C, what I want you to do is start by drawing the spur gear loads that you just calculated in problem 12.2. And it's going to look something like this. Okay, so this will be the first one. This will be the load diagram. Once we have the load diagram completed, so what we're going to do is we're going to, in the next unit, what we're going to do is talk about the chain forces, the forces on the shaft due to the chain drive at the right end of the shaft, and then we're going to be able to calculate what the reactions are at the bearings and what the torque is at the input end. So we're going to talk about that in the next lesson. But what I want you to do is draw the light lines here on sheet 3, and then draw our tangential force, which is going to be operating in the horizontal plane, and then the radial force, which is going to be operating in the vertical plane. Okay, and what I want you to do is pay very close attention to the way I've drawn the directions of these forces, because again, this is a very important element in these shaft calculations. Okay, this is the last slide. For lesson 2, we'll be working on the chain drive forces of problem 12.12 on sheet 2. Then we will be able to determine the torque distribution on the shaft. And then I'm really looking forward to lesson 2. It's going to be a lot of fun. Hope you find this informative. Hey, if you have any questions, comments, anything I can do better, let me know, guys. Thanks for playing along.